Hey guys, what's up? This is the video for section 6.5, applying systems of linear equations. So for this video, you guys need to know how to apply a system to answer a question and when you guys have an application problem, or aka word problem. But before we actually get into those word problems, let's go ahead and understand, let's learn what method is best to use when you guys want to solve a system. So you guys can see four systems here on the screen. We have one up here, the other one over here, and we have two on the bottom. Right now, I don't want you guys to solve, I don't want you guys to start doing the actual work to get the x and the y value, but let's go ahead and talk about what can we do in order to solve the system of equations. So, just a review, let's go ahead and remember what methods you can use in order to solve a system. So, the first method, you guys can actually graph the system and you guys check where the two lines intersect, and that's going to be your solution, the points of intersection. Now here's the thing about graphing. When you guys graph by hand, sometimes it's not that really accurate. For the most part, you guys can find the answer, but it's better if you guys use a graphing calculator when you guys want to solve by graphing, or an application, an app that can graph the lines for you, and you can check the lines, the two lines where they intersect. Second method is substitution method. So when you guys want to use the substitution method, you are going to take an expression of one of the equations and you are going to substitute that into the other equation. And the third method is elimination method. Now the elimination method is best when you guys have the standard form of the equations and you can eliminate one x or you can eliminate the y. So these are the three methods that you guys can use to solve a system of equations. So let's go ahead and look at the first one here. Notice that we do have one equation for this system. We have on the bottom x equals 4 minus 2y, and the variable x is by itself. So when you guys have a system with a variable by itself, doesn't matter if it's the x or the y by itself, it is best to you guys can use the substitution method. So I would use the substitution for this system, okay? So let's just go ahead and let's have an idea how you substitute and then what you do. So the expression x equals 4 minus 2y, all of this expression here, you are going to substitute into this x right there. When you guys substitute, you need to multiply the 6 times all of this expression, and then you guys combine like terms, the y's and the y's, and you solve for y. And after you get y, you go back and you substitute into one equation and you solve for the x. So the first method will be substitution, or the first system. Let's look at this one here. This one, if you guys notice, we don't have a variable by itself, but we can actually eliminate the y's. If you guys look at the y's right here, negative 5y and plus 5y, those actually eliminate. So right away, you guys can say we can use the elimination for this one. And it's just doing the work. You eliminate the y's, you add the two equations, you solve for x, you go back and you solve for y. Let's look at the next one here. Y equals 3x minus 24, 5x minus y equals 8. Well, you know what? We have the y by itself up here. Y equals 3x minus 24. So we can take all of this expression right here and you can substitute into the y in the other equation. So you can use the substitution for this system. And let's look at the last one here. The last system, well, we don't have one variable by itself. So you guys cannot substitute the expression, but we do have, look what we have, the standard form, x's and x's on top of each other, the y's and the y's, they're aligned, they're on top of each other. So we can eliminate. Which variable can you eliminate? Either one. You can choose to eliminate the x's, you can choose to eliminate the y's, and then you just solve for the variable. I think that the x is a little bit easier to eliminate on this system, because if I multiply this number by by positive 5, you are going to get a negative 55, And if you multiply this number by positive 11, you get positive 55. Negative 55 plus 55, that's going to cancel. But you also have to multiply everything by whatever number you guys multiply. So this one will be elimination method. Elimination, right? And that's how you choose a method to solve. You don't have to use elimination all the time. You don't have to use substitution all the time. You don't have to graph all the time. You just look for the best one that's going to help you solve the system and make your life a lot easier. So you just look for those tips that I mentioned in this slide and you solve. Now let's go ahead and understand how to apply a system to solve a word problem. So let's look at the next example. So this one, you can read it. It's vegetable stand. You guys have two types of vegetables. You can pause the video and just read the whole thing. But it talks about pumpkins and squashes. So it says here that pumpkins are $4 and squashes are $2 each. One day, this stand, they sold 6 more squashes than pumpkins, and the total sale or the amount they made that day is $96. We want to write a system and we want to find how many pumpkins and squashes. Yes, I know we are missing one S, so let me just put the S for squash. S-Q-U-A-S-H, squash, they sold. So let me just highlight what we want. We want to find how many pumpkins and squashes were sold that day. Let's go ahead and use the information that is given to us and let's write down the system. When you guys write a system, you always want to use variables. And the variables doesn't matter, the letter doesn't matter. You just choose one that represents something from the word problem and then you guys go from there. So notice that we are talking about squashes and pumpkins. Let me just highlight pumpkins first. So I'm going to say pumpkins, that's going to be P. So I'm going to write P equals pumpkins here. And I know that pumpkins are $4 each. So let me highlight that so I remember what it is. $4 each. Now, squashes. Squashes are $2. You guys can see the price in there. And so squashes. And I'm going to use S for squashes. I want to use a system, and I need variables. So S is going to represent squashes. Now, something that they do mention is one day they sold 6 more squashes than pumpkins. So we have to understand what that means. So let me just highlight what this is. 6 more, let me get the highlighter. 6 more squashes than pumpkins. So that means that if one day they sold 10 pumpkins, well, 6 more is 16. So they sold 16 pumpkins. So how do we get the number of squashes? So this is how you start the system. You guys will take the S for squashes equals 6 more than pumpkins. That's what it's the amount of squashes they sold. If they sell 12 pumpkins, that means 12 plus 6 is 18. They sold 18 pumpkins. All right, so I'm just going to put a little note here. Number of squashes. Now we need another equation. A system has 2 equations. So the next one is going to be the price. You guys will use the price of the 2 vegetables and the amount they made to get the next equation. So for the next one, I'm going to multiply the actual value, the price of pumpkins and squashes. Pumpkins is $4. So I'm going to take 4 times P. I multiply the number of pumpkins times the price. That's how you find the total amount you have to pay for pumpkins. Plus, and squashes is $2 each. So I'm going to put 2 times S equals the total amount, $96. So we have 96 right here. And let me just put a little note. This is the money, which means the price of the vegetables. Look at the system. On the system, we have one variable by itself, so we can use the substitution method. I want to solve. We are looking for pumpkins and squashes, P and S. So I'm going to take all of this expression right here, and I'm going to substitute into the S. So let's go ahead and do that on the side. I'm going to have the 4p plus the 2 times, and I'm going to substitute 6 plus the p into the s equals 96. And now you guys just solve. Distribute the 2. We have 4p, and we have 12 plus 2p. You guys combine like terms right here. Oops, I forgot the 96 on this side. So 4p plus 2p, that's 6p plus 12. And you guys keep going. So you guys solve, subtract the 12 from both sides. And we get 84. So p is 14. So that is pumpkins, p. Now, let's use common sense. We know that p, pumpkins, they sold that day is 14. Squashes, what do we know? It's 6 more than pumpkins. So using common sense, s will be 20. 14 plus 6 is 20. Can you guys go back? Do you need to go back and substitute the number of the p-value, the number 14, into the equation? You don't have to. You guys use common sense. So we know squashes is 6 more. You just add 6 to p. 14 plus 6 is 20. Do you need an order pair on this one? No, because it's not a point. You can, but I'm not going to ask in my class for an order pair. I just want to know how many pumpkins, how many squashes. So we have 14 pumpkins and 20 squashes. All right, let's try another one. Now, once again, guys, you can pause the video and you can read here what is the word problem, but it's basketball. You guys have points. We have a person, Star, that's the name of the player, and Star makes 16 baskets during a game. We know that in basketball, we have baskets that are worth 2 points and baskets that are worth 3 points. Yes, you guys have 1 points too, but in this problem, we're not going to talk about the 1 point basket. It's just 2 and 3. She scored a total of 40 points, and we want to write a system of equations to find how many 2-point baskets she made. So we're not looking for the 3, we're looking for just one type of baskets, 2 points. So first, let's go ahead and write down our 2 variables. We want to set up the variables so we can write down the system of equations. So I'm going to use x. X is going to represent 2 points, and y is going to represent 3 points. Can you guys use any other letters other than x and y? Yes, you can use p, you can use a, you can use b, but x and y, that's what I chose. So I'm just going to start writing the system. So first, I know, and I'm just going to highlight it, I know that she made 16 baskets right there. So I don't know how many 2-pointers, I don't know how many 3-point baskets she made, but if I add those 2 amounts, x plus the y, the number of baskets has to be 16. And let me just put a little note on the side again, number of baskets here. She can make, I don't know, 3 2 points and 13 3-point baskets. She can have 10 2 points and 6 3 points, but it had to add up to 16. That's how many baskets she made. Now, let's talk about the points. It says here that she made 40 points in that game. So when you guys add the points, it has to add up to 40. How many points are the x value? So the x value represents 2 points. So I'm going to take 2 times x plus the y is 3 points. So 3 times y, and whatever those numbers are, you multiply by 2, you multiply by 3, and then you add, has to equal 40. And this is the number of points. So I'm just going to put number of points right here. So now, remember that we are looking for one specific type of basket. We want to find how many 2 points she made that in that game. So we're not looking for the y, we are looking for the x. So that means, look at the system, x and y are on the same side, they are aligned with each other, so I can use the elimination method, and that means I need to cancel the y because I'm looking for x. So to eliminate the y, I'm going to multiply this one by -3. Why negative 3? Well, remember the y has an invisible 1 here. If I multiply negative 3 times positive 1, that's going to be negative 3. And the other y has a positive 3. So that's going to cancel. They will have the same coefficient and different sign. So I'm just going to write down the work on the side. So I'm going to distribute the top. Negative 3x minus 3y equals negative 48. The bottom equation says the same. So I'm not going to do anything to it. I'm just going to copy that down. And I'm going to add. So the y's cancel. Negative 3x plus 2x, that's going to be negative x. And on the other side, we get negative 8. You guys need to divide by negative 1 because x or the y cannot be negative. A variable cannot be negative. So that turns positive 1. And on the other side, we get a positive 8. So x represents 2 points. 8 is the number of baskets. So she made 8 baskets that are worth 2 points. Right here. Now, use common sense. If you get a negative number for this type of question or word problem, it doesn't make sense because a person cannot make negative baskets. The lowest number of baskets she can make is 0, none. Not negative 1, not negative 2. So if you guys get a negative number for this type of question, make sure you guys go back, check your work. You always want to ask yourself, does the answer make sense? Okay, so let's try the last one today. So this one here is about movie tickets, local movie theater. They give you guys the prices for adults and students. They mentioned that they sold 400 tickets and they made $620 that night. So the question is, how many adults tickets were sold? So first, let's go ahead and underline, highlight what we are looking for. We are looking for adults tickets. So let's go ahead and set up the variables. We have 2 types of tickets, adults and students. So guess what? I'm going to use A for adults and I'm going to use S for students. First of all, I know how many tickets they sold, the number of tickets, not the price, not how much, but they sold 400 tickets. So whatever number A is, whatever number S is, if you guys add the 2, A plus S, it has to equal 400. That's the number of tickets. So let me just make right here a note, number of tickets. Now the second equation, you guys will use the price, the actual money, the amount. So we know the price of adults, $2. So I'm going to take 2 times A, the number of adults tickets, plus students is $1. You don't need that 1 next to the S, but I'm just going to put it so you know that's $1 for students. And they made $620. The question is, how many adults tickets? So look at the system. We can use the elimination method because the A's are aligned, the S are aligned. So if I want to solve for A, I want to eliminate the S. So let's see. The S, we have an invisible 1 right here. So they already have the same number, but we need different sign. So I need to multiply by a negative 1. So I'm going to take the top and multiply by negative 1. Can you multiply the bottom by negative 1? Yes, but you need to multiply only one equation. Let me make a little note here on the side of the second equation. This is the actual price of the tickets, all right? So that's how you know where that equation came from. So now, let's go ahead and do the top. I'm going to distribute the negative 1. So that's going to give me a negative 8 minus 1s equals negative 400. And the bottom says the same, 2a plus 1s equals 620. Notice I'm not using the 1 next to the s. We don't need it, but we know there's a 1. So I'm going to add the 2 equations, cancel. Negative a plus 2a, that's 1a. And on the other side, negative 400 plus 620, 220. And that is the answer. So the question was, how many adults tickets were sold? 220 tickets. Can you guys use common sense and find how many student tickets were sold? Yeah, just take that number 220, subtract from 400, and you guys will get the answer for students. But right now we're just looking for adults. Okay guys, so this concludes my video. Make sure you guys practice your math, and I'll see you guys later.